Okay, guys, we're going to buzz through some of the homework right here. This section ought to go pretty fast for you, I think. You might want to pause the video and write down these special properties of a parallelogram. These are what we kind of had experimented with through all the measurements, but we're going to use some of them over here. So we do know when we do have a parallelogram that opposite sides are congruent. So I have a marked parallel right here, but they're also congruent. Opposite angles are congruent in a parallelogram. That's the second one. These two interior angles right here, angle 1 and angle 2, add up to equal 180. Okay, just like this one would over here. Those two would, just like these two would. All right. So that's what this is. Same side interior angles are supplementary. We've had that before when lines are parallel. The diagonals bisect each other. So when these diagonals are crossing, what's happening is this side, these two sides are the same, and those two are the same. And we know that these triangles are congruent. Okay, so these two triangles are congruent, and those two triangles are congruent. So that's what we say, two pair of congruent triangles. All right. So what follows after this is just basically some homework or some practice where you are applying this idea. These ones are probably right here are probably the easiest ones. Okay, let me show you a few others. Here's one. That's a parallelogram that you would have to solve. So you have to think about your properties right here. Well, we know that opposite sides are congruent. We just wrote that down. So A is 20. And we know these two are congruent. So I would have to set that to be equal to 28. And I could solve that and get 14 for B. All right. Then I know some alternate interior angles are equal. These two right here are equal. So I would say that 3y equals 42. Therefore, y is 14 once you divide. And then the other idea here for x is I need to figure out what this angle down here should be because I know it's equal to 4x. So the way I'm going to do that is I'm going to look at this whole angle up here. Well, that's 112 altogether. From here to here is 112, which according to the same side interior rule, that means this should be 68. And that means this one up here should also equal 68. So my last equation right here is 4x should equal 68, and you get x equals 14, I believe. Is that right? No, 17. 17. All right. Anyway, so you're using your properties. You're just using these. You're showing that you know those, and you're using these in these situations. Here's another one I thought I would do with you. This opposite sides are congruent, so I would just set them equal to each other. All right. When it's a parallelogram, we know this is happening, so I would just solve that out. Same thing with these alternate interior. The 3x angle should equal 45 because they're alternate interior. Here's one down here. Just a little bit of reading. It just turns into some angle solving right here. It says the measure of angle EDC is 65, so we have that labeled, and CBD is 85. Find the measure of angle CDB. Well, I do know this. If I take 85 and go alternate interior, that's because these two are parallel. I can do that. This would be 85. Then if I do linear triple, back to some old stuff right here, that's 150. So that tells me this is 30, which that means alternate interior right here, that this is 30. I can figure everything out. So that means adding these two together, that would be 115. So these would be 65 according to triangle sum. And that would be 65. So I'm sure I found CDB. If we follow CDB would be 30. I did that early on. Okay, review stuff. You've done problems like this before. All right, let's move on. Again, pause the video if you need to with the what a rectangle is. But let's draw some of this in. So the diagonals in here are congruent. Now, this is the key thing that we talked about. You know, in a regular parallelogram, these diagonals across here, one of them's longer than the other. But in order to make these diagonals the same length, I have to stand this up at 90 degrees because when it's pushed over, it's not happening. All right, but when I stand them up at 90 degrees, just like a lot of carpenters and people do when they're framing houses, they know they can measure the diagonals and make these angles be at 90 degrees. So that's the result of congruent diagonals make right angles. And then we do know that when you have one diagonal in there, you're going to have some right triangles. So there's some potential for some right triangle trig or Pythagorean theorem or anything like that. Let's do a few right here. These are pretty straightforward. It says if WY is 19, that means this whole diagonal is 19. Well, then ZX would also be 19. So that's pretty easy because we just said the diagonals are congruent. Okay. If WY is 19, then how long is WT? Well, it would be half of that. It would be 9.5 on both sides. And as a matter of fact, these would also be 9.5. Right? That would not be the case on a parallelogram. Okay. Down here, if TX is 4.5, so now we've changed the problem right here. If that's 4.5, then WY would be 9. It would have to be, because that means this one would be 9, and that one would be 9. All right. Hope you're getting the idea on those. Some of these you're going to have to draw a picture. All right. It says rectangle GALS. So you just pick a corner and go around when you put the letters down. GL is 3A plus 6. Oh, so we're talking about the diagonals already. GL, that's 3A plus 6. That's this one. And then AS is the other one. That's 5A minus 18. So I can tell right now I'm going to set these equal to each other. 3A plus 6 equals 5A minus 18. And then you guys are going to do the algebra. These are I would say elementary. It's not totally elementary, but there's just like you apply the property to these problems and you can reason it out. All right. Let's move on. These are some rectangles you will also do. These are all very workable. Just keep applying the properties. All right. This is also a rectangle one. I wanted to point out to you. It gives you some information right here that LM is 16. So you can already go ahead and fill some things out. You know that this would be 16. MN is 12. So you know this side's 12. Angle 1 is 60. So if I put a 60 in there, then I know, according to it, that it's a rectangle, that this is 90. It should be 90. So I know this has to be 30, right? And I know that this is going to be the same thing reflected over to the other side, because this triangle right here is isosceles, because those two are the same. All those are the same. So the base angle is going to be 30, which means this one's going to be 60. I could even go as far and do triangle sum. That would have to be 120. I could do vertical. So there's all these old terms that are going to be coming up, all right, that you will need to work on. The other thing you're going to need to do on this problem is you're going to need to find LN, okay, which would be this entire diagonal. We don't know any of the other diagonals, but I do know this, and I do know this. So you have to look for right triangle. That's what I said over there in my notes, that you need to be on the lookout for right triangles, because then I can find this whole diagonal, and that will help you get one of your answers over here. All right, let's move on to rhombus. Here are the notes for a rhombus. You may want to pause the video for that. But the key thing here is that the diagonals are meeting at 90 degrees now. That's a big deal. Okay. The other thing I forgot to add on here is that the diagonals bisect angles, which means these four angles in these two corners are congruent. And it also means that these four are congruent. All right. So those are the two key things for a rhombus. And then notice the definition on each of these. And then you'll see that a square is basically the definition of a rhombus and a rectangle at the same time. All right. That's why we can say that this square is considered a rhombus. It has four congruent sides. And a square is also considered a rectangle because it has four right angles. All right. So just the key thing to note on here is that when you draw in a diagonal, you are creating 45, 45, 90. So all of your shortcuts we learned in trig could be handy. The diagonals are still perpendicular, just like a rhombus. So these are 90, which means this one's 45, that's 90, They're all a bunch of 45, 45, 90s everywhere. Okay. And so there were a few of those I wanted to do with you. I think this page was some of the easier ones. I'll do a little more of the challenging ones. But it's a mixture of squares and rhombuses. Sometimes you have to draw a picture. I've worked on drawing a picture on these already. When you read this one, you have to be careful because it didn't tell you to put the diagonal in there, but it said PQS. Well, then that means that is that diagonal. So then you got to remember on a rhombus, these diagonals do bisect. Okay, and let me remind you that does not happen. That does not happen on a rectangle. If you'll recall back to the very beginning when we took all these measurements, that was not happening. So on a rectangle, that was 50 and 40. It was not bisecting that angle. All right. But on a square, it was. On a rhombus, see, it cut that 80 in half to 40 and 40. On a parallelogram, it did not bisect. All right. It's only the square and the rhombus that it bisects those angles up there. So that's what we're using right here. I'm bisecting those angles so I know they're equal to each other. So I would just set them equal to each other. 3x plus 10 equals x plus 40. And then you can do the algebra. On this one is a kind of a tricky question because it only says it's a parallelogram. However, when you continue to look at this, well, we do know in parallelograms that opposite sides are congruent, and that side's going to be congruent. We also know that opposite angles are congruent, so I know that's got to be 90. And I know that consecutive angles are, or same side interior, are supplementary, so I know that's got to be 90. That's got to be 90. So upon further review, according to the markings, you can go ahead and say with confidence, this is actually a square. Even though it only told us it's a parallelogram, it is a square. And so then it's easily doable because what that means is if this segment from here to here is 2x plus 1, well, so is this one. And that also means that this diagonal should equal this diagonal, DB, which is right here. DB, the whole thing, it says, is this 3x plus 4. So what I'm going to do is set that diagonal equal to the other diagonal. Now, the other diagonal is actually those two added together, which would be 4x plus 2. So there was a lot to piece together on that one, but very doable. Okay, another one, the diagonals of a rhombus are 10 and 24. Well, according to what I learned, I know that the 10 would be cut in half to 5 and 5, and the 24 would be cut in half to 12 and 12. I also know that they meet at 90 because this is a rhombus. All right, go back to our measurements. Look, right there on a rhombus, we measured it and they met at 90. Those met at 90. The rectangle did not meet at 90. And the parallelogram obviously did not meet at 90. All right, so that's important to remember. So if they are, find the length of a side of a rhombus because they are all the same. They're all the same Pythagorean theorem. So here we go. 5 squared plus 12 squared equals x squared. You can do the Pythagorean theorem. This rhombus is the same as the others. There we go. That's it. Parallelogram, rectangle, rhombus, and square. Those are the big four that we use most of the time. And then, one last thing to note on here is all of these characteristics we wrote down on a parallelogram, they are happening on the rectangle and the rhombus and the square because they are special parallelograms. And that's how we define them all. If you'll look back, a rhombus, it's a parallelogram with this. A square is a parallelogram with this. So it has all these characteristics plus these special characteristics. Okay? So that's kind of the hierarchy and of the way things flow. All right, good luck.